The kitchen is my favourite place in the house to do some chemistry. You can often eat the outcomes of your experiments. So today I'm looking at some spaghetti. The spaghetti is going to represent our polymer chains, okay, made of thousands and thousands of alkene monomers, all polymerized together. So, as you can see, this piece of spaghetti fits through the holes in the colander. So, with that in mind, I'd like you to form a hypothesis. What happens when I put all of these pieces of spaghetti in my colander? Okay, bearing in mind they fit through the holes. Does that match your prediction? So, even though they can fit through the holes, they haven't. Why? Well, all the different polymer strands are somehow sticking to one another. Now, in this analogy, we've got the issue of water involved in the spaghetti, but you can imagine even with the sort of long alkanes we get in these addition polymers, we've got some sort of interaction between the chains. We've got an intermolecular force, see if you can work out which one it is. If it's just like an alkane, a polyalkene, then we've got van der Waals forces between the chains, or holding them together. And one thing these chains can do, if I squash the plastic, I can start to move them around. I've got a slightly flexible plastic here. Okay, so the fact that I've got these van der Waals forces between the chains are going to keep the polymer together, prevent it from moving as though they're all individual chains. So that's the first thing about polymers I want to talk about today. The second thing, a few lessons ago I asked you if you had anything at home that you can use to represent polymers, used to represent models. Then I realised I actually own some. I own some of these, which are quite fun. Okay, I can think of each of these as my alkenes, and I'll stick them all together. Lots and lots of these all together will make a polymer. Okay? And I'm going to think about the polymer and the separate chains of polymers as stuck on my kitchen counter for the time being. Oh, it's wet, it's not going to work too well on that bit. Hopefully you can see them there. Yeah, just about. So, with these, we're going to start thinking about the flexibility of the polymer. Now, let's try and push this one and see how flexible it all is. Well, it's not, at the moment, particularly flexible. It's quite a rigid polymer because of how close those two chains are together. I can add something in called a plasticizer, which has this effect. Has the effect of moving the chains further apart. Now if I try and test their flexibility, I've actually got a lot better. Okay? I should go and answer the door.